In this video, we are going to discuss four more material parameters, which are roughness, transmission, alpha, and IOR. First is the roughness parameter. As the name suggests, the roughness parameter determines how rough or how smooth a surface is. Before the PBR standard, most 3D software use separate values to control the roughness and the reflection. This is not physically correct. In the real world, all objects are actually reflective. That is why we can see them. We can see objects because they receive lights and then bounce the lights off to our eyes. The real reason why we perceive an object as reflective is because at the microscopic level, the object's surface is almost flat, and so light rays can travel and bounce off almost uniformly. Because the reflection forms a clear image, we categorize the object as reflective. On the other hand, when an object has a rough surface, meaning that at the microscopic level, the surface has a lot of tiny mountains and valleys, the light rays that hit the surface will bounce off more randomly. Because the reflection does not form a clear image, we categorize the object as non-reflective. So again, in the real world, reflection and roughness are tied together. Because the PBR standards are based on real physics, it is easier than before as we only need to control the roughness slider. We do not need to control two different values like before. If we need to create a reflective or glossy surface, then we lower the roughness value. 0 means that the surface is perfectly glossy. You may want to use this 0 value only on glossy things like glasses, diamonds, mirrors, and so on. Notice how the reflection is very strong on lower roughness values. Vice versa, if you want to create a rough surface, then you should increase the roughness value. You want to use high roughness values on rocks, walls, dirt, carpets, etc. Again, this is just how they work commonly. On a case-by-case level, you can polish a wall or cut a stone to make it glossy, for example. Notice that when roughness value is high, the surface becomes less reflective. Now, besides for dielectrics, you can also use the roughness value for metallic objects. In the real world, with certain treatments, we can make metals look rough. For example, brushed metal. Another example is when we paint a metallic paint to a rough or porous surface, etc. On certain electronic devices or furniture, you can spot metal surfaces that are rough. So, even though they are metal, we cannot see clear reflections on their surfaces. If we want to make a material transparent or see-through, we can use either the alpha parameter or the transmission parameter. What makes them different is that transmission is physically correct, while alpha is not. Essentially, the alpha value will just make the object disappear without adding any refraction effect. So this is more suitable for visual effect purposes, such as when you need to render a ghost or 3D holographic projections like the ones you see in Star Wars movies. 1 is the default value, which makes the material fully opaque, while 0 is the minimum value that makes the object fully transparent or practically invisible. Besides visual effects, alpha is often used to create cutouts. For example, we can make a simple plain object to look like a tree leaf using an alpha texture. We will cover how to do this later when we discuss textures. Alright? If we want to make a material transparent while correctly simulating refraction, then what you should use is the transmission parameter, not the alpha parameter. For example, when you need to create glasses, liquids, diamonds, etc. If the value is at 0, which is the default, then the material is basically fully opaque. And if the value is set to 1, which is the highest value, then the material is fully refractive. For a clear glass, you want to use white for the base color and set roughness all the way to 0 or a very low value. Please note that the transmission slider tends to fog the volume of the object. That is why, personally, if I want to simulate a tinted glass, I prefer to leave the transmission value at 1 and just play around with the base color. For example, we can set the base color to dark gray to create the black tinted glass of a car window. Or you can set it to green to simulate the glass of a green bottle, and so on. Alright, let's bring this all the way to 0 again. Now, because transmission is physically correct, other physical parameters will also affect or define the end result. For example, if you set the metallic value to 1, it seems that now the transmission parameter does not work. The object is not transparent at all. Why is that? Well, this is because there is no transparent metallic material in the real world. Blender will nullify the transmission effect if you set the material to metal. So, in the real world, if you ever see a transparent material, then you can be sure that it is a dielectric material, not a metal. Another physical parameter that affects transmission is the roughness value. If you increase the roughness value, the refraction will be affected and become more and more blurry. You can use the roughness setting on glass material to simulate frosted or sandblasted glass materials. Okay? Of all the physical parameters, IOR is perhaps the most important value that works in conjunction with the transmission parameter. IOR stands for Index of Refraction. Essentially, it is a physical property that affects how much light bends when it enters or exits the object's volume. You can easily search online for the correct IOR values. As you can see, the vacuum is 1, air is almost 1, water is roughly at 1.3, diamond is about 2.4, and common glass is about 1.5, which is the default value used by Blender. You can follow these values if you want to be perfectly accurate or physically correct in your rendering. But personally, I only use 2 IOR values most of the time. I set the IOR to 1 if I want to make a balloon or anything that is transparent but filled with only air. And for the rest, I just leave the value to 1.5. The reason for this is that human eyes cannot really tell the difference between IOR values of 1.3, 1.5, and even 2.4. If a material has a refraction effect with IOR 1.5, it looks good enough to represent the other common values.